Yes, students, we are continuing the session, today's session. Okay, so I just told you that we had to continue that session because it was a lengthier one, right? So, ಅದು ತುಂಬಾ lengthy ಆಗಿತ್ತು. So, ಹಾಗಾಗಿ I had to just make another second video based on this particular topic, that is DIT-FFT, right? So, in the last video, we just understood that. So, we just understood with respect to two equations, and we just told that that equation is going to tell that the endpoint DFTs can be obtained by using 2n by 2 point DFTs, right? So now here let's understand 8 point DFT as well as what I can say the 4 point and 2 point DFT, DIT-FFT, I'm sorry, right? Yes. So what is that going to happen here is ಇಲ್ಲಿ ನೀವೇನು ತಿಳ್ಕೊತೀರಾ ಅಂದ್ರೆ ಹೇಗೆ ನೀವು 8 point DFT ಇವಾಗ ನಿಮ್ದು ಒರಿಜಿನಲ್ ಡಯಾಗ್ರಾಮ್ ಇದು ಅಲ್ವಾ. This is what is the diagram. So ಈ ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿರೋ V11 of 0, V11 of 1, V12 of 0 ಏನಕ್ಕೆ ನೀವು ಅದು ಹೆಂಗೆ ಬಂತು ಅಂತ, ಮತ್ತೆ ಇಲ್ಲಿ F1 of 0, F1 of 1, F1 of 2, whatever the output you are getting from 2 point DFT, whatever the output you are getting from 4 point DFTs, and whatever the output you are getting from 8 point DFT. So ಇಷ್ಟು ನಿಮಗೆ ಹೇಗೆ ಬರ್ತಾ ಇದೆ ಅಂತ ನೀವು ತಿಳ್ಕೋಬೇಕು. Okay, so how we are getting that? What is it is supposed to do to get the output of the 2 point DFT, which is the input of the 4 point DFT, and the output of the 4 point DFT, whatever you are getting, which is the input to 8 point DFT, right? So that one you have to remember. First ನಿಮ್ಮ input ಏನು, ನಿಮ್ಮ input ಬಂದು ಏನಾಗ್ತಾ ಇದೆ, very first thing I'll tell you about this in a neat manner. So see here, you can see that this input x of 0, x of 4, x of 2, x of 6, x of 1, x of 5, x of 3 and x of 7 all are what I can say the inputs given to you, right? But the inputs given to you are in order. Please to remember, ನಿಮ್ಮ ಕೊಟ್ಟಿರೋ ಇನ್ಪುಟ್ ಆರ್ಡರ್ ಅಲ್ಲಿ ಇರುತ್ತೆ. ಏನಾಗುತ್ತೆ ನಿಮ್ಗೆ ಆರ್ಡರ್ ಅಲ್ಲಿರೋ ಇನ್ಪುಟ್ ನಿಮ್ಗೆ ಕೊಟ್ಟಾಗ ಅದನ್ನ ನೀವು bit reverse order ಮಾಡ್ಕೋಬೇಕು. Whatever the inputs that you get in an order, you're supposed to bit reverse it. After you bit reverse it only, you're going to give it as an input to the 8 point DFT, right? So this input will be in the order, but ನೀವೀಗ ಇಲ್ಲಿ ಕೊಡುವಾಗ bit reverse order ಮಾಡಿದಿರಾ. So ನೀವು 2 point DFT ಕೊಡ್ಬೇಕಾದ್ರೆ bit reverse order ಮಾಡಿರೋದು. ಇಲ್ಲ ಅಂತಂದ್ರೆ ನಿಮ್ಮ ಒರಿಜಿನಲ್ ಕ್ವಶನ್ ಅಲ್ಲಿ ಹೆಂಗಿರುತ್ತೆ, x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6 and x of 7 ಇರುತ್ತೆ. ಸೊ ನೀವು ಅದನ್ನ bit reverse order ಮಾಡಿಬಿಟ್ಟು 2 point DFT ಗೆ ಇನ್ಪುಟ್ ಕೊಡ್ತೀರಾ. That I have already highlighted on black, what I can say, black pencil ಅಲ್ಲಿ ನಾನು highlight ಮಾಡಿದ್ದೀನಿ. I guess you can see that, right? I have highlighted there. You can see, right? That whole thing I have highlighted. So ಹಂಗೆ, so ಅದು bit reverse order ಅಲ್ಲಿ ನೀವು ಮಾಡಿಕೊಂಡು ಕೊಟ್ಟಿರೋ ಕ್ವಶನ್ ಅಲ್ಲಿರೋ ಇನ್ಪುಟ್ x of n ಅನ್ನ you are making it to bit reversed order. Which one you are making it to bit reversed order? You are making x of n in bit reversed order, and then you are supposed to give it to 2 point DFT, and that output is that output of 2 point DFT is this, that is this V11 of 0, V11 of 1, V12 of 0, V12 of 1, and this V22 of 0, V21 of 1, V22 of 0, V22 of 1. So this is all my output that I get from 2 point DFT. So that output which I get from 2 point DFT is what? It is an input to, what I can say, it's an input to my 4 point DFT. ಅದೇನು? So 4 point DFT do input, ಆಯ್ತಾ? So it is the input of 4 point DFT, and that output you get it from 4 point DFT is F1 of 0, F1 of 1, F1 of 2, F1 of 3 and F2 of 0 till F2 of 3, right? That is what is their output that you get from 4 point DFT. After that, what I supposed to do is that you are supposed to give that output to, what I can say, the as an input to 8 point DFT, and the output that you get from 8 point DFT will be in a sequential order. It will not be a bit reversed order, right? So ಏನಾಗ್ತಾ ಇದೆ ನಿಮಗೆ, ಫಸ್ಟ್ ಕೊಡ್ತಾ ಇರೋ ಇನ್ಪುಟ್ bit reversed order ಅಲ್ಲಿ ಇರುತ್ತೆ. ಹಾಗಂತ ಹೇಳಿ ನಿಮಗೆ ಇನ್ಪುಟ್ ನೇ bit reversed order ಕೊಡ್ತಾನೆ ಅಂತ ನಾನು ಹೇಳ್ತಾ ಇಲ್ಲ. I'm just trying to tell us that whatever the input that you get in the question, that is x of n. So ಆ x of n ಬಂದು normal ಆಗೇ ಇರುತ್ತೆ. You are supposed to convert it into bit reversed order, and you are supposed to give it as an input to 2 point DFT, and after when you do the 2-point DFT process and you get an output. So that output is given as an input to 4-point DFT. The 2-point DFT is output whatever you get. 2-point DFT ಇಂದ ಬಂದಿರೋಂಥ ಔಟ್ಪುಟ್ ಅನ್ನು ನೀವು 4-point DFT ಗೆ ಇನ್ಪುಟ್ ಆಗಿ ಕೊಡ್ತೀರಾ. ಮತ್ತೆ 4-point DFT ಇಂದ ಬರೋ ಔಟ್ಪುಟ್ ಅನ್ನು 8-point DFT ಗೆ ಇನ್ಪುಟ್ ಆಗಿ ಕೊಡ್ತೀರಾ. So the output that you get from 8-point DFT will be in the sequential order without fail, right? That is this one. So that is x of 0 till I'm highlighting it. See, ಕಾಣಿಸ್ತಿದ್ಯಾ? black color ಅಲ್ಲಿ round ಮಾಡ್ತಾ ಇದೀನಿ. x of 0 to x of 7, right? Yes. So now let us start learning with respect to 8-point DFTs now. Okay. So 8-point DFT ಬಗ್ಗೆ ತಿಳ್ಕೊಳ್ಳೋಣ. So I just came to this diagram because to tell you how the diagram is actually, right? So before that, so let me understand the bit reversed order. Okay, we did not understand bit reversed order. So what is bit reversed order? So bit reversed order, just a minute students, I'm so sorry I did not have anything here. Just a minute, I'm so sorry for the distraction. So how can I showcase bit reversed order here? Yeah. So bit reversed order andre ಏನಂತಂದ್ರೆ, so you are having for an 8-point DFT, sir n value ranges from 0 to 7. Okay na? 0 to 7 alva 8-point DFT andre. So ಅದಕ್ಕೆ ಏನು ಮಾಡ್ತೀರಾ, you are going to take the values from 0 to 7 and write it in digital manner. So ಏನು ಮಾಡ್ತೀರಾ ನೀವು digital form ಅಲ್ಲಿ ಬರೀತೀರಾ. So according to digital form, so how do you write it? So for your 0 it is 0 0 0, right? For your 1 I'll just write it in a neat manner. Okay, so ಅದನ್ನ ನೀವೇನ್ ಮಾಡ್ತೀರಾ, digital ಆಗಿ ಬರೀತೀರಾ. So what is 0 in digital, what is 1 in digital, what is 2 in digital, what is 3 in digital, 4 5 6 and 7 in digital, like that is supposed to write. Let me write that. If I write that, so you're going to get it as what? Just a minute. Okay. So 0 0 1, so it is 0 1 0 0 1 1. Okay, so 1 0 0, so 1 0 1 1 1 0 1 1 1, right? Yes. Okay, so this is 1 1 1, right? Yes. So what I'm supposed to do now is you're going to bit reverse this particular, right? You have a 0 and digital form. So if I consider the table with respect to the bit reversed order, so just a minute. So ನಿಮ್ಗಲ್ಲಿ bit reversed order ಆಗಿ ನಿಮಗೆ ಕೊಟ್ಟಿದ್ದಾನೆ. ಏನಂತ ಕೊಟ್ಟಿದ್ದಾನೆ? x of 0, x of 4, x of 2, x of 6, x of 1, x of 5, x of 3 and x of 7 ಅಂತ ಕೊಟ್ಟಿದ್ದಾನೆ. ಬಟ್ ನಿಮ್ಗೆ ಅದು ಹೇಗೆ ಬಂತು ಅಂತ ಹೆಂಗೆ ಗೊತ್ತಾಗತ್ತೆ ನಿಮಗೆ? ಸೊ ಅದಕ್ಕೆ ಇದನ್ನ ಹೇಳ್ಕೊಡ್ತಾ ಇದ್ದೀನಿ. ಫೈನ್. Yeah, you can see with respect to the table. Yeah, I'm here. Yes. So x of n. So these are values are in. So these values are in decimal, right? So these values are in decimal, and now these values are in binary. So I'm writing all the decimal values in binary, right? I'm writing all the decimal values in binary. So the digital ಅಲ್ಲಿ ಹೆಂಗಿರುತ್ತೆ ಅಂತ, digital is always in a binary form, right? Yes. So that is what I was about to tell you. So ನಾನು digital ಅಂತ ಹೇಳಿದ್ದೆ, but that's binary form, right? So now the whatever the digital values you have converted to binary form. So that binary form you are going to bit reverse it. So if I bit reverse it, what I'm going to get? I'm going to get 000, and I'm going to get 100. So sorry, I'm going to get as 100. I'm going to get as 010, right? So ನಾನು ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಬೈನರಿ ಡೆಸಿಮಲ್ ವ್ಯಾಲ್ಯೂದು ಬೈನರಿ ವ್ಯಾಲ್ಯೂಸ್ ಏನು ಬಂದಿದೆ ಅದನ್ನ ನಾನು ಬಿಟ್ ರಿವರ್ಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, right? So this is what is my decimal value, and I have written this in binary, and I am going to convert that binary value into bit reversed order, right? Bit reversed order ಅಂದ್ರೆ ಏನು? So 001 ಉಲ್ಟಾ ಬರೆಯೋದು, 010 ಉಲ್ಟಾ ಬರೆಯೋದು, 011 ಉಲ್ಟಾ ಬರೆಯೋದು. If I write that, I'll get 110, right? Yes. Okay. Yes. And what I can say, this is just a minute. I'm so sorry. So now what is 100? If I write it ulta, I'll get 001, right? Yes. And what if I write 101 ulta? 101 ulta baradre, I'll get once again 101 only, right? And this is 110, 011, right? And this is 111 and 111, right? So now if I write the binary values of the decimal values in the bit reversed order, so ನನ್ನ decimal value ಗೆ ಬಂದಿರುವಂತ binary values ಅನ್ನ ನಾನು bit reversed order ಅಲ್ಲಿ ಬರೆದ್ರೆ, so my decimal value once again will get changed, right? My decimal value will not be the same, right? For this it is 0, right? This is 0 and this is what? This is how much? This is 4, right? ನಾನು ಇವಾಗ ಇದನ್ನ ಉಲ್ಟಾ ಬರ್ದಿದ್ರೆ ನನಗೆ 1 ಆಗ್ತಿತ್ತು. 100, if I write it ulta, I'll get 001, that is my 1. But what's that going to happen is this is 100, so I'm getting 4. Here it is 2, right? And once again here it is 6, and once again this is 7, and once again this is 1, and once again this is how much? So this is 5, and once again this is how much? 2. I'm sorry, 3, right? Yes. So ಇದಲ್ವಾ ನಿಮಗೆ ಸಿಕ್ಕಿರೋದು. So what? X of 0, X of 4, X of 2, X of 6, X of 1, X of 5, X of 3 and X of 7. This is what you got it, right? How did you get it? You understood? Yes. So you're going to have a decimal values. Decimal values 0 to 7 matra. Yakandre it's an 8-point DFT. So for an 8-point DFT, it should be the values from 0 to 7. So 0 to 7 in the values ತಗೊಂಡು ಅದರದ್ದು ನೀವು ಬೈನರಿ ವ್ಯಾಲ್ಯೂಸ್ ನ ಬರೆದು ಆ ಬೈನರಿ ವ್ಯಾಲ್ಯೂಸ್ ಅನ್ನ ಬಿಟ್ ರಿವರ್ಸ್ಡ್ ಆರ್ಡರ್ ನೀವು ಮಾಡಿದ್ರೆ ನಿಮ್ಗೆ ಏನ್ ಸಿಗತ್ತೆ? ಯು ಸಪೋಸ್ ಟು ಗೆಟ್ ಯರ್ ರಿಸಲ್ಟೆಂಟ್ ಇನ್ ಬಿಟ್ ರಿಸಲ್ಟೆಂಟ್ ಡೆಸಿಮಲ್ ವ್ಯಾಲ್ಯೂ ಆನ್ ಬಿಟ್ ರಿವರ್ಸ್ಡ್ ಆರ್ಡರ್. This is what is the process you are supposed to do. I guess you got it, right? Yes. Now let me come back to 8-point DFT now. Okay, yeah. So according to 8-point DFT, so ತುಂಬಾ ಇದೆ. So ನಿಮ್ಗೆ ಎಷ್ಟು ಬೇಕೋ ಅಷ್ಟು ನಾನು ಹೇಳ್ತೀನಿ. Because why you have to understand how you get the resultant of 2-point DFT, how you get the resultant of 4-point DFT, how you get the resultant of 8-point DFT. ನಿಮ್ಗೆ ಅಷ್ಟೇ ಬೇಕಿರೋದು. ನಿಮ್ಗೆ ಒಂದು ಕ್ವಶನ್ ಅನ್ನ ಕೊಟ್ಟಾಗ ಅದನ್ನ ನೀವು ಬಿಟ್ ರಿವರ್ಸ್ ಹೆಂಗ್ ಮಾಡೋದು ಅಂತ ಕಲ್ತ್ಕೊಂಡಿದ್ದೀರಾ. ಈಗ ಬಿಟ್ ರಿವರ್ಸ್ಡ್ ರಿಸಲ್ಟೆಂಟ್ ಇನ್ಪುಟ್ ಆಗಿ ಕೊಡ್ತೀರಾ. ಇನ್ಪುಟ್ ಆಗಿ ನೀವು ಅದನ್ನ ಕೊಟ್ಮೇಲೆ ಸೊ ನೀವೇನ್ ಮಾಡ್ಬೇಕು? ಅದನ್ನ ನೀವು ಔಟ್ಪುಟ್ ಬರೆಸ್ಬೇಕಲ್ವಾ? 2-point DFT ಔಟ್ಪುಟ್. ಸೊ ಅದು ಹೇಗ್ ಬರೆಸ್ತೀರಾ ನೀವು? ಒಂದ್ ಇನ್ಪುಟ್ ಅನ್ನ ಇಟ್ಕೊಂಡು ಅಂತ ನೀವು ಕಲ್ತ್ಕೋಬೇಕು. ಅದನ್ನ ನೀವು ಕಲ್ತ್ಕೊಂಡ್ಮೇಲೆ ಮತ್ತೆ ತಿರ್ಗಾ ನೀವು 4-point DFT ಇನ್ಪುಟ್ ಅನ್ನ ಇಟ್ಕೊಂಡು ಇನ್ಪುಟ್ ಅನ್ನ ಇಟ್ಕೊಂಡು 4-point DFT ಔಟ್ಪುಟ್ ಅಥವಾ 8-point DFT ಇನ್ಪುಟ್ ನ ಹೇಗೆ ನೀವು ಬರೆಸ್ತೀರಾ ಅದನ್ನ ನೀವು ತಿಳ್ಕೋಬೇಕು ಅಷ್ಟೇ. ಯು ಆರ್ ಸಪೋಸ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದಾಟ್ ಮಚ್. ಬಿಕಾಸ್ ಡೋಂಟ್ ಗೋ ಇನ್ ಟು ಮಚ್ ಡೀಪರ್ ಥಿಂಗ್ಸ್. ಬಿಕಾಸ್ ಪ್ರಾಬ್ಲಮ್ಯಾಟಿಕ್ ಸಬ್ಜೆಕ್ಟ್ಸ್ ಏನಾಗುತ್ತಂದ್ರೆ ನಿಮ್ಗೆ ಮೊದ್ಲೇ ಕೆಲವೊಂದು ಕಷ್ಟ ಇರುತ್ತೆ. ನೀವು ಅದ್ರ ಮಧ್ಯದಲ್ಲೂ ನಾನು ಅದರದ್ದು ಇದು ತಿಳ್ಕೊತೀನಿ, ಅದು ತಿಳ್ಕೊತೀನಿ, ಅಲ್ಲಿ ಹೋಗ್ತೀನಿ, ಇದ್ರ ಬಗ್ಗೆ ಇನ್ಫಾರ್ಮೇಶನ್ ತಿಳ್ಕೊತೀನಿ ಅಂತ ನಾನು ಹೋದ್ರೆ ಖಂಡಿತ ಇಟ್ ಇಸ್ ನಾಟ್ ಎಟ್ ಆಲ್ ಪಾಸಿಬಲ್. ಬಿಕಾಸ್ what's that going to happen is you will get confused. First of all ನಿಮ್ಗೆ ಅದು ಅರ್ಥ ಆಗ್ದೇನೆ ಒದ್ದಾಡ್ತಿರ್ತೀರಾ. ನಾನು ಅದ್ರ ಮೇಲೂ ಇನ್ನೂ ಕಲಿತೀನಿ ಅಂದ್ರೆ ನಿಮ್ಗೆ ಇನ್ನೂ ಕನ್ಫ್ಯೂಸ್ ಆಗುತ್ತೆ. ಸೊ ಅವಾಗ ನೀವೇನ್ ಮಾಡ್ಬೇಕು? if there is any tougher concepts that is in front of you and if you're struggling to understand that and if you just try to say that I'm learning more and more things on that, then it is very much difficult. ಸೊ ಯಾವ್ದಾದ್ರು ಕಷ್ಟದಿದ್ಯಾ? ನಿಮ್ಗೆ ಅದ್ರಲ್ಲಿ ಏನ್ ಬೇಕೋ ಅದನ್ನ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ಅದನ್ನ ಎಕ್ಸಾಮ್ ಹಾಕ್ಬಿಟ್ಟು ಬನ್ನಿ ಸಾಕು. ತುಂಬಾ ತಲೆ ಕೆಡಿಸ್ಕೊಂಡು ಡೋಂಟ್ ಮೇಕ್ ಯೋರ್ ಮೈಂಡ್ ಗೆಟ್ ಯೋರ್ ಮೈಂಡ್ ಸ್ಟ್ರೆಸ್ಡ್, ಆಯ್ತಾ? ಸೊ ನಿಮ್ ಮೈಂಡ್ ಅಲ್ಲಿ ನೀವೇ ಒಂದು ಗೊಂದಲಗಳು ಅಥವಾ ಈ ಮ್ಯಾಗಿ ಆಗತ್ತಲ್ಲ ಆ ತರ ಮಾಡ್ಕೋಬೇಡಿ ಮೈಂಡಿಗೆ, ರೈಟ್? ಡೋಂಟ್ ಮೇಕ್ ಯೋರ್ ಮೈಂಡ್ ಅಸ್ ಅ ಮ್ಯಾಗಿ ಆರ್ ಸಮಥಿಂಗ್ ಅಂಡ್ ಆಲ್ಸೋ ಪ್ಲೀಸ್ ಟು ಟ್ರೈ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ನಿಮ್ಗೆ ಏನ್ ಬೇಕು ಅದ್ರಲ್ಲಿ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ, ಅಷ್ಟೊಂದು ಓದ್ಕೊಳ್ಳಿ, ಅಷ್ಟೊಂದು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ಎಕ್ಸಾಮಿನೇಷನ್ ಪಾಯಿಂಟ್ ಆಫ್ ವ್ಯೂ ಏನ್ ಬೇಕೋ ಅದನ್ನ ಓದ್ಕೊಳ್ಳಿ, ಹೋಗಿ ಬರದ್ಬಿಟ್ಟು ಬನ್ನಿ, ಆಯ್ತಾ? ಚಿತ್ರಾನ್ನ ಎಲ್ಲ ಮಾಡ್ಕೊಳಕ್ ಹೋಗ್ಬೇಡಿ. ಡೋಂಟ್ ಮೇಕ್ ಯರ್ ಕಾನ್ಸೆಪ್ಟ್ ಅಸ್ ಚಿತ್ರಾನ್ನ ಆರ್ ಮೊಸರನ್ನ. ಪ್ಲೀಸ್ ಟು ಟ್ರೈ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ವಾಟ್ ಇಸ್ ರಿಕ್ವೈರ್ಡ್ ಫಾರ್ ಅರ್ ಎಕ್ಸಾಮ್. ಏನ್ ಬೇಕು ಅದರಲ್ಲಿ ನಿಮ್ಗೆ ಎಕ್ಸಾಮಿಗೆ ಆ ಕಾನ್ಸೆಪ್ಟ್ ಇಂದ ಏನ್ ಬೇಕು ತಿಳ್ಕೊಳ್ಳಿ, ಅದನ್ನ ನೀಟಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ, ಅದನ್ನ ಓದ್ಕೊಳ್ಳಿ, ಅದನ್ನ ಎಕ್ಸಾಮಿಗೆ ಬರೆದ್ಬಿಟ್ಟು ಬನ್ನಿ ಸಾಕು. ಓಕೆ, ಇಫ್ ಇಟ್ ಇಸ್ ಅನ್ ಈಸಿಯರ್ ಕಾನ್ಸೆಪ್ಟ್ ನೀವು ಎಷ್ಟು ತಿಳ್ಕೊಳ್ಳಿ ಬೇಡ ಅನ್ನಲ್ಲ. ಬಟ್ ನಿಮ್ಗೆ ಅದು ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ನಿಮ್ಗೆ ಕನ್ಫ್ಯೂಸ್ ಅನ್ನಿಸ್ದಾಗ ನೀವು ಇನ್ನಷ್ಟು ತಿಳ್ಕೊತೀನಿ ಅಂತ ದಯವಿಟ್ಟು ಹೋಗಕ್ ಹೋಗ್ಬಿಡಿ ಅದ್ರ ಮೇಲೆ. ಸೊ ಅದನ್ನ ನೀವು ಫಸ್ಟ್ ನಿಮ್ಗೆ ಎಲ್ಲಿ ಕನ್ಫ್ಯೂಸ್ ಆಗ್ತಿದೆ ಅದನ್ನ ಅರ್ಥ ಮಾಡ್ಕೊಳಕ್ ನೋಡಿ ಸಾಕು. ಆಮೇಲೆ ನೀವು ಬೇರೆ ನೋಡೋರಂತೆ. ಫೈನ್? ಎಸ್, ದಟ್ ಇಸ್ ವಾಟ್ ಐ ವಾಸ್ ಅಬೌಟ್ ಟು ಟೆಲ್ ಯು. ಓಕೆ, ಲೈಕ್ ಹಾಗಂತ ವಿಷಯನೇ ತಿಳ್ಕೊಬೇಡಿ ಅಂತ ಅಲ್ಲ, ಬಟ್ ನಿಮ್ಗೆ ಅದು ಎಲ್ಲೋ ಒಂದ್ ಕಡೆ ಕಷ್ಟ ಇರುತ್ತೆ. ಸೊ ಅವಾಗ ನೀವೇನ್ ಮಾಡ್ಬೇಕು? ಕಷ್ಟ ಇರೋದನ್ನ ನಾನು ಹೆಂಗ್ ಸುಲಭ ಮಾಡ್ಕೋಬೇಕು ಅಂತ ಮಾತ್ರ ಯೋಚನೆ ಮಾಡಿ ಹೊರತು ಅದ್ರ ಮೇಲೆ ನಾನು ಇನ್ನೂ ಬೇರೆ ಬೇರೆ ವಿಷಯ ತಿಳ್ಕೊತೀನಿ ಅಂತ ದಯವಿಟ್ಟು ಹೋಗ್ಬೇಡಿ. ದಟ್ ಇಸ್ ವಾಟ್ ಐ ಆಮ್ ಟ್ರೈಂಗ್ ಟು ಟೆಲ್ ಯು. ಓಕೆ, ಎಸ್. So here it is. Let's consider an 8-point DIT-FFT for better understanding. Okay, have that in the next page. So this is my 8-point DIT-FFT. Fine. Yes. So figure 3.2.1 shows that the 8-point DFT can be computed directly and hence no reduction in computation. Right? So 8-point DFT is computed directly. There is no reduction in computation. You need not to do any other process for that. Right? Yes. So here according to equation 3.2.7 and equation 3.2.8, that is this one. According to these two equations, x of k can be obtained from f1 of k as well as f2 of k. So how we are going to find out? We are going to find out by using f1 of k and f2 of k, right? Yes. So what is that going to happen is that, so you are supposed to here f1 of k and f2 of k are two 4-point DFTs. So f1 of k and f2 of k are two 4-point DFTs. So that is here you saw. So this is f1 of k over here in the equation and this is f2 of k over here in the equation. So those two equations are set to be my 4-point DFTs, right? Those two are set to be my 4-point DFTs, that is two 4-point DFTs. Okay. So here you can see this the symbolic diagram for this operation, that is this one, right? Yes. And 3.22 and in 3.22 observe that for 8 point x of n, d sequences f1 of m and f2 of m are given, right? I told you with respect to this f1 of m and f2 of m. ನಾನು ಹೇಳಿದ್ದೆ ಅಲ್ವಾ in the last session I've told you about that. Okay, you can see here, right? This one and this one. Okay, yes. So see here you can see I've told you with respect to that yeah, here f1 of m and f2 of m. What is this f1 of m and f2 of m? So they are splitted into two n-point data sequences. So those are two n by 2 data sequences you are splitting out. That is 8-point DFT data sequence. You are going to split out into two data sequence. That is 2 n by 2. That is two 4-point data sequence you are going to split up into. And then that is what is you are going to tell us what, that is f1 of n and f2 of n. So that is what is this f1 of m and f2 of m right here, where yeah, this. Okay, yeah, given there. So that is what is that. Okay, so ಇಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾನೆ. So ಇದು ಏನು ಅಂತ ನೀವು ಸಡನ್ ಆಗಿ ತಲೆ ಕೆಡಿಸ್ಕೋಬೇಡಿ. So it is like we have already discussed in the beginning that so the two 8-point DFTs are divided into what I can say, the two 8-point DFTs are divided into n by 2-point DFT wherein so it is f1 of m and f2 of m, and that is what is this particular, right? Yes. So here f1 of m is equal to x of 2n and f2 of m is equal to x of 2n plus 1. So this one we have already told you. See, navilla helidivi. So see here we have told no. So this f1 of m is consisting of even number of sequence, that is x of 2n, and f2 of n is consisting of now the m terminology badlaiskondidivi, right? For some reason we have changed to m terminology and you can see that, right? f2 of m is equal to x of 2n plus 1, right? Yes. And then yeah, so and then yes, so next thing what you're supposed to see is that, so see here, that is what is this, and here you can see that we are trying to substitute the values of n, right? So ನಿಮಗೆ ಇಲ್ಲಿ x of 0, x of 2, x of 4, x of 6 ಬರಕ್ಕೆ ಮತ್ತೆ x of 1, x of 3, x of 5 and x of 7 ಬರಕ್ಕೆ ನಿಮಗೆ substituting the value of n. If you substitute for 2, n is equal to 0 over here, x of 2n ಗೆ ನಾವು n is equal to 0 ಮಾಡಿದ್ರೆ 2 into 0 which is equal to 0, right? Yes. And x of 2 into 1 which is equal to 2, right? Yeah. And x of 2 into 2. So if you substitute n is equal to 2, so then you are going to get it as 2 2s are 2 into 2 which is equal to 4, right? And once again you are supposed to get it as what I can say, this x of 4. Okay, don't forget it is x of 4. Just a minute. Yeah. So this x of 2, I got it, right? Yeah. So this is equal to what I can say, the others one, right? Here it is, just a minute. I'll just rewrite it again. Yeah. I'm so sorry. Yeah. So just a minute, students. I'll rewrite that again. Okay. Yeah. So here you can see that, yeah. Mm. So just a minute, yeah. So if I substitute x of 2n as my given, that is for even sequence. So for x of 2n, so if it is what I can say, if you substitute x of 0, so that is x of 2 into 0, which is equal to what? X of 0, right? Yes. And once again it is what I can say, if I substitute x of 2 and 2 1, so which is equal to, which is equal to x of 2, right? X of 0, x of 2, like that. Here if you substitute 2 here, you get it x of 4. Yes, yes. Okay. And whether it is x of, here it is, if you substitute x of 2 into 3, which is equal to x of 6, right? Yes. So here it is x of 6. So you need not to substitute n is equal to 4 because it leads to x of 8, wherein x of 8 is not at all prohibited, right? Because it's 8-point DFT, wherein the range starts from 0 to 7. Okay. And here if you try to substitute n here, 2n plus 1. So what is x of 2n plus 1? If you try to substitute x of 2n plus 1, so you're going to get it as what I can say, the 2 into what I can say 1, which is equal to 2 into 0. I'll substitute 2 into 0. I'm sorry, the very first value is 0. So 2 into 0 plus 1, which is equal to x of 2. No, no, 1. I'm sorry, 1. Okay, yeah. Yeah. This is equal to what I can say, the x of 1, and then yeah, so next it is what I can say, the x of what I can say, the 1. So if I substitute 1 here, I'll be getting my resultant as 2 into 1 is 2, 2 plus 1 is 3. Like that, if I substitute 2, what I'm going to get? 5, x of 5. So 2 into 2 is 4, 4 plus 1 is 5. And then if I try to substitute what I can say, the x of how much? If I try to substitute my x of 4, so you can't substitute x of 4, right? Just a minute, I'll just check it. This is x of 1, x of 2. Yeah, if I try to substitute x of 3, I get it as 2 into here. If I try to substitute 3, it is 2 into 3 is 6, 6 plus 1 is 7, right? Yes, so you'll get the resultant. So these resultant, that is x of 1, 3, 5, 7 is for 2n plus 1, 0, 2, 4, 6 is my 2n, right? Did you get it? So these are all even numbered sequence and these are all odd numbered sequence. So you got to know how did you get that, right? So let me erase it. Yeah, I'm sorry. So just a minute, I'll erase this so that it would be helpful for you. Fine? Yeah. Yeah. So this is what is you got to understand, right? Now in figure 3.22, two n by 2 point DFTs are to be computed separately and they are combined as per the equation 3.2.7 and equation 3.2.8 to get n point DFT. So here I told you that we are going to have two n by 2 point DFT separately, that is 4 point DFT separately, and you are going to combine as per these two equations. So you are going to combine as per these two equations. So you are going to get the resultant as what I can say, n to get n point DFT, right? Yes. And now here once again we are back with f1 of n and f2 of n. There it was m. Once again we are back with f1 of n and f2 of n, right? So then next what is supposed to do is that we know that f1 of n and f2 of n are n by 2 point sequences. Let f1 of n be splitted into even numbered and samples and odd numbered samples as follows. So now we have divided f1 of n and f2 of n, right? I have already told you 8 point DFT na 2 n by 2 point DFT divide ಮಾಡಿದೀವಿ. ಅದು f1 of n and f2 of n ಅಂತ. ಸೊ ಮತ್ತೆ ನೀವು ಆ f1 of n ಮತ್ತೆ f2 of n ಅನ್ನ ಡಿವೈಡ್ ಮಾಡ್ತಿದ್ದೀರಾ. ಹೇಗೆ? By splitting into even and odd number of samples, you're going to split into even and odd number of samples. So if you split it, you're going to get it as v11 of n is equal to f1 of 2n v12 of n is equal to f1 of 2n plus 1. That is what you're supposed to do is that, so ನೀವು f1 of n ಅಲ್ಲಿ n ಅನ್ನ ನೀವು ಈವನ್ ನಂಬರ್ಡ್ ಸ್ಯಾಂಪಲ್ ಮತ್ತೆ ಆಡ್ ನಂಬರ್ಡ್ ಸ್ಯಾಂಪಲ್ ಅಂತ ಡಿವೈಡ್ ಮಾಡ್ತೀರಾ. ಅದರಲ್ಲಿ ನಿಮಗೆ v11 of n ಬಂದ್ಬಿಟ್ಟು f1 of 2n ಅಂದ್ರೆ ಏನು, ಸೊ v11 of n ಎಲ್ಲ ಬಂದ್ಬಿಟ್ಟು ನಿಮಗೆ ಈವನ್ ನಂಬರ್ಡ್ ಆಫ್ ಸ್ಯಾಂಪಲ್ಸ್ ಇರುತ್ತೆ, ಮತ್ತೆ v12 ಎಲ್ಲ ಬಂದ್ಬಿಟ್ಟು ಆಡ್ ನಂಬರ್ಡ್ ಸ್ಯಾಂಪಲ್ಸ್ ಇರುತ್ತೆ. ಸೊ ದಟ್ ಇಸ್ n is equal to 0, 1, n by 4 minus 1 and n is equal to 0, 1, n by 4 minus 1. ಹೇಗೆ ಅಂತಂದ್ರೆ, ಸೊ ಇದು v11 and v12 of n. ಸೊ v11 ನೀವು ತಗೊಂಡ್ರೆ, ಲೆಟ್ ಮಿ ಜಸ್ಟ್ ಹ್ಯಾವ್ ಅ ಬ್ರೀಫ್ ಹಿಯರ್. ಸೊ ವಾಟ್ ಇಸ್ v11 of n? ಸೊ v11 of n ನೀವು ಕರೆಕ್ಟ್ ಆಗಿ ನೋಡ್ಕೊಳ್ಳಿ. ಸೊ ದಿಸ್ ಇಸ್ v11 of n is having my just a minute, not here. Okay, I'm so sorry, wait a second. N by 4 minus 1. Yeah, okay. And then here I'm sorry for the distraction that happened in between. And then here you can see that, so now let's come to the next point. Here observe that v11 of n is even numbered sequence of f1 of n. So v11 of n is an even numbered sequence of f1 of n, and what I can say, the v12 of n is the odd numbered sequence of what I can say the f1 of n, right? So here we are considering v11 as all the even numbered sequence that is present in f1 of n, and v12 of n is all the odd numbered sequence of f1 of n, right? So since f1 of n contains n by 2 samples, v11 of n and v12 of n contains what? It contains n by 4 samples, right? What does it contains? N by 4 samples. N by 4 samples in the sense they are 2-point DFTs, right? So v11 of n and v12 of n, they are containing n by 2 samples. Okay, yes. So similarly, if you try to split f2 of n, so v2 of n is equal to f2 of 2n and v22 of n is equal to f2 of 2n plus 1, right? Yes, so just a minute, I'm so sorry, I'll just check with this once. Yeah, so here it is what I can say. Yeah, okay. So here we are trying to tell what? Here we are trying to tell that we are going to identify here we are trying to tell that, so according to our 8-point DFT, so ನಮ್ಮ 8-point DFT ಪ್ರಕಾರ ಅರ್ಥ ನಾವು ಅದನ್ನ ಎರಡು ಪಾರ್ಟ್ ಆಗಿ ಡಿವೈಡ್ ಮಾಡಿದೀವಿ, wherein it is f1 of m and f2 of m. So f1 of m is containing all even sequences and f2 of m is containing all odd numbers. So that one we showed how to do it. Okay, so here I told you that n by 2-point DFTs are computed separately and they are clubbed together according to these two equations, right? According to these two equations they are clubbed together. Okay, and then now we are coming to second stage of declination, and here we told that f1 of n and f2 of n are n by 2-point sequences, and f1 of n is being divided into even number of samples and odd number of samples as follows. So when you try to divide f1 of n as even numbered and odd numbered, so what you are supposed to get? You are supposed to get it as what I can say, the v11 of n is equal to that f1 of 2n and v12 of n is equal to f1 of 2n minus 1, 2n plus 1, which is what I can tell it as v11 of n is all odd even numbered sequence and v12 of n is odd numbered sequence. Like that, in the same way, so in the case of f2 of n also we are considering v21 of n is equal to f2 of 2n and v22 of n is equal to f2 of 2n plus 1, right? Okay, so this is for the range n is equal to 0 to n by 4 minus 1. So now here v21 is even numbered sequence of f2 of n and v22 is odd numbered sequence of f2 of n, right? And both v21 and v22 of n contain n by 4 samples each, right? Yes, so now we obtained x of k and x of k plus n by 2, that last equation we had got it. So now by having, so from f1 of k and f2 of k we got it, wherein we had the declination as f1 of n and f2 of n, right? So now the length of DFT was n by 2. Similarly, here we are going to find out f1 of k and f1 of k plus n by 4 from v11 of k and v12 of k, wherein we are going to get the resultant as, so that is equal to Okay, so that is equal to f1 of k is equal to v11 of k plus omega n by 2 whole to the power of k, v12 of k, and f1 of k n plus 4 is equal to v11 of k plus omega n by 2 whole to the power of k, v12 of k, right? What you're supposed to do is you've got an equation like this, right? In the place of this equation, here you're going to write f1 of k, right? So here what is that going to happen is you're going to find what I can say f1 of k, and that is what your f1 of k plus n by 4 we are going to find out. Here we found out x of k and x of k plus n by 2. Now here we are finding f1 of k and f1 of that is k plus n by 4, right? Yes, that is k plus n by 4 wherein, okay, that is k plus n by 4, wherein what I can say here by we are making finding out that from v11 of k and v12 of k, right? See here we are finding out that by using the v11 of k here and v12 of k. Instead of f1 of k and f2 of k, we are writing v11 of k and v12 of k, and here we are supposed to write that as omega of n by 2 whole to the power of k. Why n by 2? Because it is omega 4 to the power of k. That is why we are going to write it as n by 2 to the power of k. Here it is omega n, that is omega 8 to the power of k. Here it is omega 4 to the power of k. That is why we are supposed to write like that. Okay. Yes, I guess you understood. So ಇಲ್ಲಿ ಏನು ಇಲ್ಲ, ನಾವು x of k ಮತ್ತೆ x of k plus n by 2 ನ ನಾವು ಕಂಡುಹಿಡಿದಿದ್ದೀವಿ. ಸೊ ಅದೇ ರೀತಿ ನಾವು f1 of k ಮತ್ತೆ f1 of k plus n by 4 ಅನ್ನ ಕಂಡುಹಿಡಿತಾ ಇದ್ದೀವಿ. ಹೇಗೆ ಕಂಡುಹಿಡಿತಾ ಇದ್ದೀವಿ? ನಾವು v11 of k ಮತ್ತೆ v12 of k ನ ಉಪಯೋಗಿಸಿಕೊಂಡು ಕಂಡುಹಿಡಿತಾ ಇದ್ದೀವಿ. k ನೋ ಏನೋ ಜಸ್ಟ್ ಅ ಮಿನಿಟ್, ಯಾ, k ನ ಉಪಯೋಗಿಸಿಕೊಂಡು ಕಂಡುಹಿಡಿತಾ ಇದ್ದೀವಿ. ಸೊ ಅದಕ್ಕೆ ನಾವು ಇಲ್ಲಿ v11 of k ಮತ್ತೆ v12 of k ಬರೀತಾ ಇದ್ದೀವಿ. ಇಲ್ಲಿ x of k ಮತ್ತೆ x of k plus n by 2 ಜಾಗದಲ್ಲಿ f1 of k ಮತ್ತೆ f1 of k plus n by 4 ನ ಬರೀತಾ ಇದ್ದೀವಿ, right? And then instead of omega n to the power of k, we are trying to write omega of n by 2 plus k because it is omega 4 to the power of k. So n by 2 ಅಂದ್ರೆ n 8 ಆಗಿದ್ದಾಗ 8 by 2 will become equal to 4. So that is omega 4 to the power of k, right? And here this is resulting in that only. Okay, yes. So now coming on to here, the range is from 0 to n by 4 minus 1. Okay, so now compare the above two equation with equation 3.27 and 3.28. In 3.27 and 3.28 endpoint DFT, I'm sorry, endpoint DFT is obtained from 2n by 2 point DFTs, right? ಅಲ್ಲಿ ನಾನು ಏನು ಹೇಳಿದೆ, n point DFT ನಮಗೆ ಹೇಗೆ ಸಿಗುತ್ತೆ, 2n by 2 point DFT ನ ಸಿಗ್ತಾ ಇದೆ. ಆದ್ರೆ ನಮಗೆ ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ, n by 2 point DFT ನಮಗೆ 2n by 4 point DFT ಇಂದ obtain ಆಗ್ತಾ ಇದೆ, ರೈಟ್? ನಾವಲ್ಲಿ ಏನ್ ಹೇಳಿದ್ವಿ, ಸೊ ಎರಡು ಈಕ್ವೇಶನ್ ಅನ್ನ ನೋಡ್ಕೊಂಡು ಈ ಎರಡು ಈಕ್ವೇಶನ್ I'm sorry, by seeing these two equations here, that is by seeing these two equations here, I just told that you are going to get the n point DFT by using 2n by 2 point DFT, but by this equation I am telling that you are going to get the n by 2 point DFT by using how much, 2n by 4 point DFTs. So ಎರಡು n by 4 point DFTs ಇಂದ ನಿಮಗೆ 2n by 2 DFT ಬರ್ತಾ ಇದೆ ಅಂತ ಈ equation ಪ್ರೂವ್ ಮಾಡ್ತಾ ಇದೆ, ಆಯ್ತಾ? Yes. So I guess you understood things in a better manner. So yeah, so now we can write the equation for f2 of k. So now ಇದೇ ತರ f2 of k ಒಂದು equation ಬರೆದಿದ್ದೀವಿ. So f2 of k ಗೆ ಸೇಮ್ equation, ನೀವು f1 ಬದಲು f2 ಬರೀತೀರಾ, v11 ಬದಲು v21 ಬರೀತೀರಾ ಇಲ್ಲಿ, and v12 ಬದಲು v22 ಬರೀತೀರಾ, ಇಲ್ಲಿ n by 2 ಹಾಗೆ ಇರುತ್ತೆ, right? Yes. So now here you can see that here v21 of k is n by 4 point DFT of v21 of n, and v22 of k is n by 4 point DFTs of v22 of n, right? So illa ಹೇಳಿದ್ವಲ್ಲ ಅದೇ ತರ, just yes. And now recall the example of 8 point DFT. Just a minute, if you require this I'll tell you. Okay, yes, yeah, yeah. So this is what is for 4 point DFT students. So you require this, I'll tell you. So now let's recall the example of 8 point DFT. So now you got how to find out what I can say the this one, that is 8 point DFT, right? This is what is you are supposed to ಫೈಂಡ್ ಔಟ್. ಸೊ ಇವಾಗ ನಾವೇನ್ ಮಾಡಿದೀವಿ, ವೆರಿ ಫಸ್ಟ್ 8 ಪಾಯಿಂಟ್ DFT ಕಂಡುಹಿಡಿಯೋದನ್ನ ಕಲ್ತಿದೀವಿ. ಯಾವುದು? ದಿಸ್ ಇಸ್ ವಾಟ್ ಇಸ್ ದರ್ 8 ಪಾಯಿಂಟ್ DFT ಐಡೆಂಟಿಫಿಕೇಶನ್. ಸೊ ದಿಸ್ ಇಸ್ 8 ಪಾಯಿಂಟ್ DFT ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದಕ್ಕೆ ಹೀಗೆ ಕಲ್ತಿದೀವಿ. ಓಕೆ, ಜಸ್ಟ್ ಅ ಮಿನಿಟ್. ಯಾ, ಐ ಆಮ್ ಸೊ ಸಾರಿ. So this is what is your 8 point DFT, right? So ಇದು ನಿಮ್ಮ 8 point DFT ಮತ್ತೆ yes, yes, yes. So this is what is you are supposed to, this equation is you're supposed to find out 8 point DFT, and this equation is trying to tell you how you're supposed to find out the 8 point the 4 point DFT, right? So now we are coming coming to know how to find out 2 point DFT, right? Yes. So ಇದು 4 point DFT ಕಂಡುಹಿಡಿಯೋಕಿರುವಂತ ಮೆಥಡ್. ಓಕೆ, ಐ ಗೆಸ್ ಯು ಅಂಡರ್ಸ್ಟೂಡ್. ನಾನು ಪ್ರತಿಯೊಂದನ್ನು ಲೈನ್ ಬೈ ಲೈನ್ ತೋರಿಸಿದ್ದೀನಿ ಅಂಡ್ ಲೈನ್ ಬೈ ಲೈನ್ ಕೂಡ ನಾನು ಏನೇನು ಅಂತ ಹೇಳಿದ್ದೀನಿ. ಓಕೆ, ಸೊ ಈ V11 of K and V12 of K ಏನು? ಸೊ ನಾವಿಲ್ಲಿ ಹೇಳಿದೀವಲ್ಲ. ಸೊ we have already told here that we are going to divide F1 of n by what? F1 of n by even number and odd number of samples ಗೆ ನಾವು ಡಿವೈಡ್ ಮಾಡಿದಾಗ V11, V12, V21, V22 ಸಿಗತ್ತೆ. ಆಮೇಲೆ ನಾವು ಅದೇ F1 of n ಮತ್ತೆ F1 of n F1 of K ಮತ್ತೆ F1 of K plus n by 4 ನ ಕಂಡುಹಿಡಿಯೋದಕ್ಕೆ ನಾವೇನ್ ಮಾಡಿದ್ವಿ, V11 of n DSP ನ ತಗೊಂಡ್ವಿ, with DFT ನ ತಗೊಂಡ್ವಿ, which is V11 of K, and here it is V12 of K, right? I guess you understood each and everything what I told you, right? Yes. Okay, and now coming on to this particular, so here it is what I can say, my F1 of K and F2 of K are two 4 point DFTs computed directly and are represented by single blocks as shown in this particular figure. Okay, so F1 of K can be obtained from V11 of K and V12 of K as per the equation that particular. Okay, F1 of K can be obtained from this V11 of K and V12 of K by using this particular equation, these two, right? Yes. And now this one, first one, not second one. I'm sorry, not second one, it's the first one. Okay, and now coming on to, for n is equal to 8, V11 of K and V12 of K will be n by 4, that is 2 point DFTs, right? Yes. So what is my F1 of K and F2 of K? It was my n by 2 point DFT, but V11 of K and V12 of K is what is my n by 4 point DFT, right? Yes. So now coming on to this figure 3.2.4a. So this is showing the symbolic diagram for this operation. In this figure, observe that for 4 point, F1 of m in the sequence, V11 of n and V12 of n are given in equation. So here it is V11 of n, wherein F1 of 2n is equal to x of 4n. So F1 of 2n is equal to what I can say, my x of 4n. Why 4n? Because it is n by 4 point sequence. So that is why I take it as x of 4n. Right? Yes. So V11 of n andre ಏನು? F1 of 2n ಅಂತ ನಾನು already ಹೇಳಿದ್ದೀನಿ. Here I have told you, right? You can see. So this is V11 of n is equal to F1 of 2n. So which is equal to what? That is x of 4n. As we are, why we are trying to take 4n? Because it is what is my 4, that is here what I can say, the this one. Which one? 4 point F1 of n. So that is why I am going to take x of 4n. I'm sorry, so I'm going to get it as x of 4n is equal to, here if I try to substitute 4 into 0, which is equal to x of 0, and 4 into 1, which is equal to x of 4, right? Yes. And then now if I try to substitute 4n plus 2, so 4n plus 2 nalli nan substitute madidre n barutte, so I'm going to get it as what I can say, that is x of, what I can say, 4 into 0 plus 2. 4 into 0 plus 2 is my 2, and 4 into 1 plus 2 is my 6, right? So I'm going to get it as x of 2 comma x of 6, right? Yes. So this is what is I'm going to get it, wherein it is equal to n by 4 point sequences, right? Yes, that is what is you got it. See, here it is x of 0 and x of 4, and here it is x of 2 and x of 6. So that means these two are joined together, right? Yes, you can see here in the diagram. So just a minute. Yeah. X of 0 and, I'm so sorry, just a minute, I'll just take some time. X of 0 is connected to x of 2 x of 0, x of yeah, correct, it is correct. Okay, so here ಏನ್ ಸಿಕ್ತು ನಿಮಗೆ ರಿಸಲ್ಟ್ ಅಂದ್ರೆ, ಸೊ ನಿಮಗೆ 4 ಪಾಯಿಂಟ್ DFT ಹೇಗಾಗಿದೆ ಅನ್ನೋದಕ್ಕೆ ಒಂದು ಎಕ್ಸಾಂಪಲ್. ಸೊ ಈಗ ನಾವು ಈ 4 ಪಾಯಿಂಟ್ DFT ಲೇನ್ ಡಯಾಗ್ರಾಮ್ ಕಾಣಿಸ್ತಿದೆಯಲ್ಲ, ಈ ಕಂಪ್ಲೀಟ್ ಡಯಾಗ್ರಾಮ್ ನಿಮಗೆ ಹೇಗಾಯ್ತು, x of 0, x of 4, x of 2, x of 6 ಈ ಎರಡನ್ನು ಕ್ಲಬ್ ಮಾಡಿದಾಗ, ಸೊ ಈ ಎರಡನ್ನು ಕ್ಲಬ್ ಮಾಡಿದಾಗ ಸಿಗುವಂತಹ ವೆರಿ ಫಸ್ಟ್ 4 ಪಾಯಿಂಟ್ DFT ಇದು. ಸೊ ಅದನ್ನೇ ನಾವು ಇಲ್ಲಿ ಪ್ರೂವ್ ಮಾಡಿದೀವಿ. ಹೆಂಗೆ ಪ್ರೂವ್ ಮಾಡಿದ್ವಿ, ವಿ ಪ್ರೂವ್ಡ್ ಇಟ್ ಬೈ ಗಿವಿಂಗ್ ಅನ್ ಈಕ್ವೇಶನ್ ಸೇ x of 4n and x of 4n plus 2. ಸೊ ಇದನ್ನ ನಾವು ಮಾಡಿದಾಗ ನಮ್ಗೆ ಇಲ್ಲಿ x of 0 ಮತ್ತೆ x of 4, x of 2 ಮತ್ತೆ x of 6 ಬರುತ್ತೆ. ಸೊ ಈ ಎರಡನ್ನು ಸೇರಿಸಿ ನಾವು ಕ್ಲಬ್ ಮಾಡಿದಾಗ ನಮಗೆ 4 ಪಾಯಿಂಟ್ DFT ಬರುತ್ತೆ. ಹಾಗೇನೆ ಇಲ್ಲಿ 8 ಪಾಯಿಂಟ್ DFT ಕೂಡ if I have not told I'll tell you. ಸೊ ಹಿಯರ್ ಅದಕ್ಕೆ ನಿಮ್ಗೆ ಈ ರಿಸಲ್ಟ್ ಬಂದಿರೋದು. ಎಲ್ಲೋ ರಿಸಲ್ಟ್ ಏನ್ ಬಂದಿತ್ತು ನಿಮ್ಗೆ ಚೆಕ್ ಮಾಡ್ಕೊಂಡ್ರ ಹಿಯರ್. So I have got x of 0, x of 2, x of 4 and x of 6, x of 1, x of 3, x of 5 and x of 7. So ಈ ನಾಲ್ಕು ವ್ಯಾಲ್ಯೂಸ್ ಅನ್ನು ನೀವು ಒಟ್ಟಿಗೆ ಸೇರಿಸಿದಾಗ ಏನಾಗುತ್ತೆ, ನಾಲ್ಕು ವ್ಯಾಲ್ಯೂಸ್ ಅನ್ನು ಒಟ್ಟಿಗೆ ಸೇರಿಸಿದಾಗ so it is like you get one 4 ಪಾಯಿಂಟ್ DFT. This is one 4 ಪಾಯಿಂಟ್ DFT and this is one 4 ಪಾಯಿಂಟ್ DFT. ಸೊ ಈ ಎರಡನ್ನು ಸೇರಿಸಿದಾಗಲೇ 8 ಪಾಯಿಂಟ್ DFT ಆಗುತ್ತೆ. ಅದಕ್ಕೆ ನಿಮ್ಗೆ ಇಲ್ಲಿ ಕೊಟ್ಟಿರೋದು ಈ x of 2n ಮತ್ತೆ x of 2n plus 1 ಕೊಟ್ಟಿರೋ ರೀಸನ್ ಏನಕ್ಕೆ ಅಂತಂದ್ರೆ, ನಿಮ್ಗೆ ಯಾವ್ಯಾವ್ದನ್ನ ನೀವು ಕ್ಲಬ್ ಮಾಡಿದ್ರೆ 8 ಪಾಯಿಂಟ್ DFT ಆಗುತ್ತೆ, ಯಾವ್ಯಾವ್ದನ್ನ ಕ್ಲಬ್ ಮಾಡಿದ್ರೆ 4 ಪಾಯಿಂಟ್ DFT ಆಗುತ್ತೆ ಅನ್ನೋದಕ್ಕೆ ತೋರ್ಸಕ್ಕೋಸ್ಕರ ಕೊಟ್ಟಿದ್ದಾನೆ. ಸೊ ಇಲ್ಲಿ ನಿಮ್ಗೆ ಈ ತರ ವ್ಯಾಲ್ಯೂಸ್ ಬಂದಿದೆ. ಸೊ ಇದೆರಡನ್ನು ಇಷ್ಟನ್ನು ಒಟ್ಟಿಗೆ ಕ್ಲಬ್ ಮಾಡಿದಾಗ ನಿಮ್ಗೆ ಒಂದು 4 ಪಾಯಿಂಟ್ DFT ಸಿಕ್ತಲ್ವಾ, ಕರೆಕ್ಟ್, ಯು ಗಾಟ್ ಇಟ್. yes, so here you are supposed to write that the downward. ಸೊ ನೀವು ಡೌನ್ವರ್ಡ್ ಗೆನೆ ಒಮೆಗಾ 4 to the power of 0 and omega 4 to the power of 1 ಬರಿಬೇಕು. Okay, so next you can see that the two n by 4 ಪಾಯಿಂಟ್ DFTs are to be computed separately and then they are combined as per equation 3.2.12 and equation 3.2.13 to get n by 2 ಪಾಯಿಂಟ್ DFTs of f1 of k. ಅಂದ್ರೆ ನಿಮ್ಗೆ ಇಲ್ಲಿ ಏನ್ ಹೇಳ್ತಾ ಇದ್ದಾನೆ, ಸೊ ಟು n by 4 ಪಾಯಿಂಟ್ DFTs are to be computed separately. ಸಪರೇಟ್ ಆಗಿ ನೀವು ಕಾಂಪ್ಯೂಟ್ ಮಾಡ್ಕೋಬೇಕಾಗುತ್ತೆ. ಮತ್ತೆ ನೀವು ಅದನ್ನ ಹೇಗೆ ಕಂಬೈನ್ ಮಾಡ್ತೀರಾ, ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕಂಬೈನ್ ಬೈ ಯೂಸಿಂಗ್ ದ ಈಕ್ವೇಶನ್ ಸೇ ದಟ್ ಇಸ್ 3.2.12. ಸೊ ದಿಸ್ 3.2.12 ಮತ್ತೆ ಈ 3.2.13 ಅನ್ನು ಉಪಯೋಗಿಸ್ಕೊಂಡು ನೀವು n by 2 ಪಾಯಿಂಟ್ DFT f1 of k ಗೆ ಬರ್ತೀರಾ. ಅಂದ್ರೆ ಏನು, f1 of k ಬರೋದಕ್ಕೆ ನೀವು ಏನ್ ಮಾಡ್ಬೇಕು, ಸೊ ಅದನ್ನೇ ನಾನು ಇಲ್ಲಿ ಹೇಳಿದ್ದು 4 ಪಾಯಿಂಟ್ DFT ಅಂತ. ಸೊ ನಾನು ಏನಕ್ಕೆ 4 ಪಾಯಿಂಟ್ DFT ಅಂತ ಹೇಳಿದೆ, ದಿಸ್ ಈಕ್ವೇಶನ್ ಇಸ್ 4 ಪಾಯಿಂಟ್ DFT. ಸೊ ಈ 4 ಪಾಯಿಂಟ್ DFT ಔಟ್ಪುಟ್ ಬರ್ಬೇಕಾದ್ರೆ ನೀವು 3.2.12 ಮತ್ತೆ 3.2.13 ಅನ್ನ ಉಪಯೋಗಿಸ್ತೀರಾ. 8 ಪಾಯಿಂಟ್ DFT ನೀವು ಔಟ್ಪುಟ್ ಬರ್ಬೇಕಾದ್ರೆ 3.2.7 and 3.2.8 ಅನ್ನು ಉಪಯೋಗಿಸ್ತೀರಾ. ಅದನ್ನೇ ಇಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾನೆ ಕ್ಲೀನ್ ಆಗಿ. yes, you can see here, right? So here here you can see. So here what is that is that, so compare the above two equations with just a minute. Ello kottidane, I'll just showcase to you here. Yeah, so see here we obtained x of k and x of k plus n by 2 by using 3.2.7. just a minute, I have seen somewhere. Okay, yeah, just a minute students, I'll just showcase to you. Fine, yeah. So ಈ ತರ ಒಂದು ಅಲ್ಲೆಲ್ಲೋ ಇತ್ತು. So separately I've showcased to you. just a minute, I'll just come back and showcase to you. Here. So see, this is two n by 2 ಪಾಯಿಂಟ್ DFTs are to be computed separately and they are combined as per these two equations to get n-ಪಾಯಿಂಟ್-DFT. ಅಂದ್ರೆ ನೀವು 8 ಪಾಯಿಂಟ್-DFT ಬರಬೇಕು ಅಂತಂದ್ರೆ ನಿಮ್ಗೆ 4 ಪಾಯಿಂಟ್-DFT ನ ಸಪರೇಟ್ ಆಗಿ ಕಾಂಪ್ಯೂಟ್ ಮಾಡ್ಕೋತೀರಾ. ಅದೆರಡನ್ನು ನೀವು ಕ್ಲಬ್ ಮಾಡಿದಾಗ 8 ಪಾಯಿಂಟ್-DFT ಬರುತ್ತೆ. ಅದು ಹೇಗೆ ಅಂತಂದ್ರೆ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಮೇಕ್ ಯೂಸ್ ಆಫ್ 3.2.7 and 3.2.8 equation. ಸೊ ನಿಮ್ಗೆ ಏನ್ ಗೊತ್ತಾಗಬೇಕು, ಈ ಈಕ್ವೇಶನ್ ಗೊತ್ತಾಗಬೇಕು, ಮತ್ತೆ ನಿಮಗೆ ಈ ಈಕ್ವೇಶನ್ ಇದು ಮತ್ತೆ ಇದು ಗೊತ್ತಾಗಬೇಕು, ಮತ್ತೆ ನಿಮ್ಗೆ ಯಾವ ಈಕ್ವೇಶನ್ ಗೊತ್ತಾಗಬೇಕು, ಇನ್ನೊಂದು ಈಕ್ವೇಶನ್, ಎರಡು ಈಕ್ವೇಶನ್ ನಿಮಗೆ ಗೊತ್ತಾಗಬೇಕು. ಓಕೆನಾ, and still one more you need to get to know, that one also will come here. Okay, so now here that is what I was about to tell you. ನಾನು ಅದನ್ನೇ ಹೇಳಿದ್ದು, ಇಲ್ಲಿ ಏನು ಇನ್ಫಾರ್ಮೇಶನ್ ಇಲ್ಲ. ನಾನೇನ್ ಹೇಳಿದೆ ನಿಮ್ಗೆ v11 of 0, v11 of 1 ಎಲ್ಲ ಹೆಂಗ್ ಕಂಡುಹಿಡಿತೀರಾ, ಮತ್ತೆ f1 of 0 ಹೆಂಗ್ ಕಂಡುಹಿಡಿತೀರಾ, ಮತ್ತೆ x of 0 ಹೆಂಗ್ ಕಂಡುಹಿಡಿತೀರಾ ಅಂತ ಅನ್ನೋದಕ್ಕೋಸ್ಕರ ಏನೇನ್ ಈಕ್ವೇಶನ್ ಉಪಯೋಗಿಸ್ಬೇಕು ಅಂತ ನಾನು ತೋರಿಸ್ಕೊಟ್ಟಿದ್ದೀನಿ. ಕರೆಕ್ಟಾ? ಎಸ್. And now here you can see that, so that is what I can say, let's see this. Okay, 3.2.4. This figure shows the computation of F2 of K as per equation 3.2.14 and 3.2.15. Right? So now F2 of K henge construct ಮಾಡೋದು ಅಂದ್ರೆ second part henge construct ಮಾಡೋದು ಅಂತ ಈ diagram ಅಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾನೆ. And then here you can see the two n by 4 point DFTs are combined in this figure. Observe that n by 4 point sequences V21 and V22 of n sequences are given in equation. So ನಮಗೆ V21 V22 ಬೇಕು ಅಂದ್ರೆ ನಾವೇನ್ ಮಾಡಬೇಕು? It is what I can say my x of 4n plus 1 and x of 4n plus 3. Right? Yes, ಏನಕ್ಕೆ ನಾವು x of 4n plus 1 ಮತ್ತೆ 4n plus 3 ಅಂತ ತಗೋತಾ ಇದೀವಿ ಅಂತಂದ್ರೆ so we are going to do n by 4 point sequence. So ಅದಕ್ಕೋಸ್ಕರ ನಾವು x of 4n plus 1 ಅಂತಂದ್ರೆ ನಮಗೆ 1 and 5 ಬರುತ್ತೆ. n ಗೆ ನೀವು 0 1 substitute ಮಾಡಿ 1 and 5 ಬರುತ್ತೆ. ಇಲ್ಲಿ n ಗೆ 0 and 1 substitute ಮಾಡಿ you are supposed to get it as 3 and 7. Right? Yes, that is what I am supposed to get. ಆಯ್ತಾ? So now V21 and V22 of n ಏನ್ values ಅಂತ ಪತ್ತೆ ಹಚ್ತಾರೆ. V21 of n ಅಂದ್ರೆ V21 of 0 and V21 of 1 ಅಂತ. So this n is 0 to 1. So ನಮಗೆ V21 of 0 ಅಂತಂದ್ರೆ ಏನ್ ಬರುತ್ತೆ? 1 ಬರುತ್ತೆ. x of 1 ಬರುತ್ತೆ. V22 of what I can say which is equal to 1 ಅಂತಂದ್ರೆ you're supposed to get it as x of 5. Right? Like that here also V22 of 0 is x of 3 and V22 of 1 is x of 7. Right? Yes. And then what you're supposed to do is that you're supposed to this is what is that diagram. Okay. So now you're going to supposed to find out computation of 2 point DFT. So 2 point DFT do V11 V12 ಅದನ್ನೆಲ್ಲ ನೀವು ಹೇಗೆ ಕಂಡುಹಿಡಿಯಬೇಕು ಅನ್ನುವಂಥದ್ದನ್ನ ನಾವು ಹೇಳ್ಕೊಡ್ತೀವಿ. ಓಕೆ, ಸೊ ದಟ್ ಇಸ್ ದೇರ್ ಇಸ್ ಆಲ್ಸೋ ಸಮ್ ಸರ್ಟನ್ ಈಕ್ವೇಶನ್ ಫಾರ್ ದಟ್. ಆಯ್ತಾ? ನಾವು ಇಲ್ಲಿ V21 of n and V22 of n ಏನಕ್ಕೆ ಕಂಡುಹಿಡಿದ್ವಿ ಅಂದ್ರೆ ಏನದು ಅಂತ. ಸೊ ಅದು x1 of 0 ನ ಅಥವಾ x1 of 1 ನ x1 of 2 ನ ಆ ತರ ಕಂಡುಹಿಡಿತಾ ಇರೋದು ಹೊರತು we have not learned how to get V11 of n as well as V12 of n, V2 of n and V22 of n. ಇಷ್ಟು ನೀವು ಹೇಗೆ ಕಂಡುಹಿಡಿಯೋದು ಅಂತ ಕಲ್ತಿಲ್ಲ. ನೀವೇ ಕಲ್ತಿರೋದು x of n ನ ಹೇಗೆ ಕಂಡುಹಿಡಿತೀರಾ, x of 0, x of 1, x of 2, x of 3, x of 4 ಅದನ್ನ ಹೇಗೆ ಕಂಡುಹಿಡಿತೀರಾ ಅಂತ ಮಾತ್ರ ಕಲ್ತಿರೋದು. ಮತ್ತೆ ನೀವು f1 of n ಅಂದ್ರೆ ಇದು ಯಾವುದು ನೀವು ಇದನ್ನ ಕಂಡುಹಿಡಿಯೋದು ಕಲ್ತಿದ್ದೀರಾ. ಒಂದು ಈಕ್ವೇಶನ್, ಯಾವ ಈಕ್ವೇಶನ್ 3.2.7 and 8 ಈಕ್ವೇಶನ್ ಹೇಳೋದಲ್ಲ ಅದು. ಮತ್ತೆ ಇದಕ್ಕೊಂದು ಇದನ್ನ ಹೇಗೆ ಕಂಡುಹಿಡಿಯೋದು ಅಂತ ಕಲ್ತಿದ್ದೀರಾ. ದಟ್ ಇಸ್ f1 of 0 till f1 of 7 ಹೇಗೆ ಕಂಡುಹಿಡಿಯೋದು ಅಂತ ಕಲ್ತಿದ್ದೀರಾ. ಸೊ ಯು ಹ್ಯಾವ್ ನಾಟ್ ಸ್ಟಿಲ್ learn to find out V11 of 0, V11 of 1 like that. ಅದನ್ನೆಲ್ಲ ನೀವು ಇನ್ನೂ ಕಂಡುಹಿಡಿಯೋ ಕಲ್ತಿಲ್ಲ. So that one we are supposed to learn it here. Right? Yes. And here you can see that the n by 4 point sequences in equation 3.2.110 and 3.2.111. So that has been split into their even and odd part. So n by 4 point sequences of 3.2.110 ಯಾವುದು 3.2.110 ಮತ್ತೆ 11 ಇದು ಅಲ್ವಾ. ಸೊ ಇದು 3.2.110 and 11. ಸೊ ಇದನ್ನ ಮತ್ತೆ ಇದನ್ನ ನಾವು ಸ್ಟಿಲ್ ಡಿವೈಡ್ ಮಾಡ್ತಾ ಇದೀವಿ. So when we still divide, so here you can see that we get the next stage of declination and sequence will be of length n by 8. The procedure discussed can till now be repeated further to compute the DFT. ಅಂದ್ರೆ ನಿಮಗೆ n by 4 point sequences ಅಂದ್ರೆ ನಮಗೆ V11, V12, V21, V22 ನ ನಾವು ಸ್ಟಿಲ್ ಮೋರ್ ಸ್ಪ್ಲಿಟ್ ಮಾಡಿದಾಗ ನಮಗೆ ಏನ್ ಸಿಗುತ್ತೆ, we are going to get the resultant as length n by 8. right? n by 8 ಲೆಂತ್ ಬರುತ್ತೆ. ಸೊ ಪ್ರೊಸೀಜರ್ ನೀವು ಡಿಸ್ಕಸ್ ಮಾಡಿದಾಗ ಸೊ ಯು ವಿಲ್ it can be repeated until and unless you get the DFT. Still we reach to 2 point DFT. Right? Since n is equal to 2 to the power of v, we reach to 2 point DFT is after v minus 1 decimation. For example, for n is equal to 8, we perform 3 minus 1, 2. Since v is equal to 3 decimations, and we reach to 2 point DFT as shown in figure 2.4. Right? For n is equal to 8, we perform 2 decimations and we reach to 2 point DFT. Right? Yes. So now, I'm sorry. So now let's see how 2 point DFTs can be evaluated. Right? Yes, let's see that. Okay, then yeah. And I'm so sorry students, just a minute, I'll just be back. Okay, yeah. I'm so sorry for the distraction that happened. Okay, yeah. So see here you can see that we are supposed to find out how 2-point DFTs can be calculated, right? ನಾವೀಗ very first ಕಲ್ತಿದ್ದೇನು 8-point DFT ದು resultants ಹೇಗೆ calculate ನಾವು ಮಾಡ್ಕೊಂಡಿದ್ದೀರಾ ಅಂತ, right? Yes, 8-point DFT ದು resultant ಹೇಗೆ calculate ಮಾಡ್ತೀರಾ by using the equation this 3.2.7 and 3.2.8 and then 4-point DFTs ನ ಹೇಗೆ calculate ಮಾಡ್ತೀರಾ by using this equation that is 3.2.12, 3.2.13, 3.2.14 and 3.2.15 ಈ ನಾಲ್ಕು ಈಕ್ವೇಶನ್ ಸೇರಿಸಿ ನಾವು 4-point DFT ನ ಕಂಡುಹಿಡ್ಕೋತೀವಿ. Okay, so I guess you understand how to identify that, right? So I have taught you in a neat manner. So if any issues you can just post it in the comment section, right? Yes, and here you can see that so this is a V11 of n. So ನಾವೀಗ ಮತ್ತೆ ಏನು ಮಾಡ್ತಾ ಇದೀವಿ, so ನಾವು ಇವಾಗ ಮತ್ತೆ ನಾವೇನ್ ಮಾಡ್ತಾ ಇದೀವಿ, we are trying to discuss how to calculate 2-point DFT. So 2-point DFT ಗೆ calculate ಮಾಡ್ತೀರಾ. So how do you calculate the output of 2-point DFT? That is what we are trying to understand. Okay, so ನಾವಿಲ್ಲಿ V11 of n, V12 of n, V21 of n and V22 of n ಅನ್ನ ನಾವು ಕಂಡುಹಿಡಿಯೋದಕ್ಕೆ ನಿಮಗೆ ಏನ್ ಹೇಳಿದೆ, we have what I can say, I'm so sorry. So V11 of n, V12 of n, V21 of n and V22 of n ಅನ್ನ ನಾವು ಕಂಡುಹಿಡಿಯೋದಕ್ಕೆ ಸೊ ಈ ತರದೊಂದು ಮಾಡ್ಕೊಂಡಿದ್ದೇವೆ. ಸೊ ಇದೇನು ಅಂತಂದ್ರೆ ನಿಮ್ಗೆ x ವ್ಯಾಲ್ಯೂಸ್ ಏನು ಅಂತ, ಸೊ ಈ ವ್ಯಾಲ್ಯೂಸ್ ಏನು ಅಂತ, ಸೊ ಈ ಎರಡು ವ್ಯಾಲ್ಯೂಸ್ ನ ನೀವು ಕ್ಲಬ್ ಮಾಡಿದಾಗ ನಿಮಗೆ 4-point DFT ಒಂದು ಬರುತ್ತೆ, ಮತ್ತೆ ಇಲ್ಲಿರೋ ಎರಡು ವ್ಯಾಲ್ಯೂನ ಕ್ಲಬ್ ಮಾಡಿದಾಗ 4-point DFT ಒಂದು ಬರುತ್ತೆ. ಸೊ ಈ x of 0, x of 4, x of 2 ಮತ್ತೆ x of 6 ಕ್ಲಬ್ ಮಾಡಿದಾಗ ಬಂದಂತ 4-point DFT ಇದು. ಓಕೆ, ಅಂಡ್ ಈ 4-point DFT ಬಂದ್ಬಿಟ್ಟು ಸೊ ದಟ್ ಇಸ್ x of 1, x of 5, x of 3 and x of 7 ಕ್ಲಬ್ ಮಾಡಿದಾಗ ಬಂದಿದಂತಹ ಒಂದು 4-point DFT. ಸೊ ಅದಕ್ಕೆ ಇದನ್ನ ನಾವು ಪ್ರೂವ್ ಮಾಡಿದ್ದೀವಿ, ರೈಟ್? ಸೊ ದಿಸ್ ಇಸ್ n by 4-point sequences. So you are going to club 4 and 2 n by 4-point sequences to get one 4-point DFT, and you are going to club 2 n by 4-point sequences to get one 4-point DFT, right? Yes. And then now we are supposed to see here that so 2-point DFT ಕಂಡುಹಿಡಿಯೋಕೆ ಕಲ್ತ್ಕೊಳ್ಳೋಣ. So this is n-point DFT by the definition. It is x of k is equal to n is equal to 0 to n minus 1. So that is x of n is equal to omega x of n into omega n kn, right? Yes, and here you can see the computational here you can see the computation of 2-point DFTs V11 of k of figure 3.2.4, right? So this is figure 3.2.4a. Just a minute. 3.2.4a, right? Yes, so this is one diagram. Okay, and here you can see that from figure 3.2.5 we can see that, okay, this is what which was written in figure 3.2.4a, right? Illi bardidalla, you can see this one, the same thing is telling you, right? Yes, so figure 3.2.4a according to that is written the same. And then let's see the computation of 2-point DFT V11 of k using 3.2.4a. So from figure 3.2.5 we can write equation 3.2.18. So this equation if you try to write by making use of 3.2.5 as, so instead of x of n we write V11 of n, right? V11 of k. So if you want V11 of k you are supposed to write V11 of n. So here we are trying to compute V11 of k. So V11 of k na ನಾವು compute ಮಾಡಬೇಕು, ಅದು 2-point DFT. ಅದು compute ಮಾಡೋಕ್ಕೋಸ್ಕರ ನಮಗೆ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, this becomes V11 of n, right? And this is omega 2 to the power of kn. How omega 2? It is omega n by 4 kn. n by 4 kn ಅಂದ್ರೇನು 8 by 4 which is equal to 2. So that is what is directly written over here. Okay, yes, and then coming on to the next one. So for k is equal to 0, it is V11 of 0 is equal to n is equal to 0 to 1, V11 of n is into omega 2 to the power of 0. So it is V11 of n into what? It is omega 2 to the power of 0, right? So this is what is for k is equal to 0, right? Now k is equal to 0 ನಲ್ಲಿ substitute ಮಾಡಿದ್ವಿ, right? If I substitute my k is equal to 0, I get the summation of n is equal to 0 to 1, that is V11 of n, right? So if I come to the next one, so na next one bartini anta andre, so I would be getting my resultant as V11 of 0 plus V11 of 1, right? I am going to get my resultant as that is equal to V11 of 0 plus V11 of 1, right? That is what is I am going to get my resultant as, okay? And then next, what is supposed to do is that for k is equal to 1, what you are going to get the resultant, right? Yes, for k is equal to 1, what you are going to get the resultant? For k is equal to 1, what you are going to get the resultant is this resultant, right? So, ಈ resultant ನಿಮ್ಗೆ ಹೇಗೆ ಬರ್ತಾ ಇದೆ ಅಂದ್ರೆ ನಾನು ಹೇಳಿಲ್ಲ ಅಲ್ಲ, yeah. Here you are trying to substitute, here your range is from n is equal to 0 to 1. ಅದಕ್ಕೆ ನಾನು v11 of 0 plus v11 of 1 ಅಂತ ಬರ್ತಿದ್ದೀನಿ. ಅಂದ್ರೆ ನಾನು n ವ್ಯಾಲ್ಯೂನ 0 and 1 ಅಂತ substitute ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ. My n is equal to 0, 1, right? It's changing from 0 to 1. So my n is only two values, 0 and 1. ಅದಕ್ಕೆ ನಾನು ಈ n ಜಾಗದಲ್ಲಿ 0 ಮತ್ತೆ 1 ಅನ್ನ substitute ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ. So summation ಅಂದ್ರೆ ಏನು? It's a addition of two values, right? Addition of two or more values, as I can say it as my summation, right? ಅದಕ್ಕೆ ನಾನು v11 of 0 plus v11 of 1 ಅಂತ ಬರ್ಕೊಂಡಿದ್ದೀನಿ, right? I guess you understood, right? It is written by the textbook, but I am telling you how is written it, okay? Yes, just a minute. Okay, so I guess you understood this, right? So ನಾನು ಏನಕ್ಕೆ ಹಂಗೆ ಬರೆದಿದ್ದೀನಿ ಹಿಂಗೆ ಅಂತಂದ್ರೆ ನಾನು n is equal to 0, 1. So n is summation ಇದೆ ಅಲ್ವಾ, ಸೊ ಅದಕ್ಕೆ ನಾನು ಆಡ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. So I am putting n value as 0 and I am adding with this n value 1. Okay, ಅದೇ ತರ ನಾನು v11 of 1 ಕಂಡುಹಿಡಿತೀನಿ. For k is equal to 1 ಅಂದ್ರೆ, so I'll get n is equal to 0 to 1, summation of n is equal to 0 to 1. Why summation of n is equal to 0 to 1? Because it's a 2-point DFT. So for my 2-point DFT, it is n changes from 0 to 1. Right, that is what is I've written over here, and it is v11 of n into omega 2 to the power of k. And I told you omega n by 4 kn, wherein my n is equal to 8, 8 by 4 is 2. Right, yes, and here which is equal to, I substitute n what? I substitute n is equal to 0 again. And what I can say, just a minute, I'm so sorry. So here, yeah, we have substituted 1 here. How is that? So it is omega n to the power of kn. So n agide 2 agide, capital N. So k into n. So nanu k ge 1 substitute ಮಾಡಿದಾಗ, what I am going to get? I am going to get it as omega 2 to the power of n itself, right? ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? So this is omega 2 to the power of kn, wherein my k is equal to 1. I just substituted my k is equal to 1, wherein I remain with 1 into n, which is equal to n, right? Yes. So this is what is that. So here I will directly substitute 0 and 1 value. ನಾನು 0 and 1 substitute ಮಾಡಿದಾಗ n ಗೆ ಇಲ್ಲಿ first 0 substitute ಮಾಡ್ತೀನಿ. So this will be like this. Okay. If I try to substitute 1, I will get omega 2 to the power of 1. What is omega 2 to the power of 0, which is equal to 1? So I am directly getting it as v11 of 0. Right? Yes. And it is plus, what I can say, what is omega 2 to the power of 1? Omega 2 to the power of 1 ಬಂದ್ಬಿಟ್ಟು, so that is e to the power of minus j 2 pi by 2 into 1, which I am going to get it as, what I can say, this is e to the power of minus j 2 pi by n is equal to omega of n. So I get it as, what I can say, e to the power of minus j pi. So when, which is equal to cos pi minus j sin pi, which is equal to minus 1. So that is omega 2 to the power of 1 is minus 1 always. So therefore I am going to get it as, what I can say, so I am going to get it as, that is equal to v11 of minus 1. Right? I am going to get it as minus v11 of 1. Okay. Yes. So how I am going to get that as that, ಇಲ್ಲಿ ನಿಮಗೆ v11 of 0 into, ನಿಮ್ಗೆ ಇಲ್ಲಿ ಏನು ಬರ್ತಾ ಇದೆ, v11 of 0 into omega 2 to the power of 0. Thus omega 2 to the power of 0 is what? Which is my 1, right? So I'm going to directly get it as v11 of 0. And once again here it was plus v11 plus v11 into 1, v11 of 1. This is into omega 2 to the power of 1. My omega 2 to the power of 1 is minus 1. So if I try to multiply with minus 1, I am going to get this resultant as, that is v11 that is minus V11 of 1, right? I am going to get that resultant. Okay, so then I have to get this resultant, and I wrote it over here. So now once again we know that V omega 2 to the power of 0 is equal to 1. So now let's multiply V11 of 1 by V2 omega 2 to the power of 0 in equation 3.2.20 and equation 3.2.22. So that is why yeah, here in this equation and in this equation we are trying to multiply V11 by omega 2 to the power of 0. So now ಏನು ಮಾಡ್ತಾ ಇದೀವಿ, this equation whatever I have tick marked over here, you can see this equation and this equation. For this equation you are going to multiply V11 of 5 by omega 2 to the power of 0, right? And note this does not make any difference. Now 3.2.20, just a minute, I'm so sorry for the distraction, right? Yes, it is 3.2.20 and 3.2.22 equation will become equal to what it will become equal to. So I'll just erase this. This is what is for this thing, right? Yes, yeah. Okay, so you're going to get the resultant as what? You're going to get the resultant as that is V11 of 0 plus omega 2 to the power of 0 into V11 of 1, and V11 of 1 is equal to V11 of 0 into omega 2 to the power of what I can say, that is 0 V11 of 1, right? So what is trying to tell is trying to tell us this V11 of 1 ಇಲ್ಲಿ ಏನಿದೆ, ಸೊ ಇಲ್ಲಿ V11 of 1 ಇದೆ ಅಲ್ವಾ, ಅದಕ್ಕೆ ನೀವು omega 2 to the power of 0 ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕು. ಇಲ್ಲೂ ಒಂದು V11 of 1 ಇದೆ ಅಲ್ವಾ, ಸೊ ಇದಕ್ಕೂ omega 2 to the power of 0 ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕು. ಅವಾಗ ನಿಮಗೆ ಈ ಈಕ್ವೇಶನ್ ಬರುತ್ತೆ. ಓಕೆನಾ? ಸೊ you'll get this equation, right? So for all others it is the same. So ಪ್ರತಿಯೊಂದಕ್ಕೂ ಹೀಗೆ ಬರುತ್ತೆ. ಹೇಗೆ ಬರುತ್ತೆ? So you're supposed to get it as for the computation is illustrated in figure 3.2.6. Similar equation and similar flow graph can be obtained by other 2-point DFTs, right? Other 2-point DFTs ಗೆ ನಿಮಗೆ ಇದೇ ತರ ಒಂದು equations ಬರುತ್ತೆ. Okay, so this is what is for this particular session. And ನಿಮಗೆ ಹೇಗೆ ಕಂಡುಹಿಡಿಯಬೇಕು ಅಂತ ಗೊತ್ತಾಗಿದೆ ಅಂತ ಅನ್ಕೊಂಡಿದ್ದೀನಿ. I've told you each and everything in detail. So I've told you I'm sorry. So I've told you with respect to this particular. So V11 of n ಹೇಗೆ ಬಂತು ಎಲ್ಲಾನು ಕ್ಲೀನ್ ಆಗಿ ಹೇಳಿದ್ದೀನಿ. So I guess you can understand that, and I am going to make a list of equations, right? 8-point DFT ಕಂಡುಹಿಡಿಯೋದಕ್ಕೆ ಯಾವ equation ಉಪಯೋಗಿಸಬೇಕು, 4-point DFT ಕಂಡುಹಿಡಿಯೋದಕ್ಕೆ ಯಾವ equation ಉಪಯೋಗಿಸಬೇಕು, 2-point DFT ಕಂಡುಹಿಡಿಯೋದಕ್ಕೆ ಯಾವ equation ಉಪಯೋಗಿಸಬೇಕು ಅಂತ ನಾನು ನಿಮಗೆ ಹೇಳ್ಕೊಡ್ತೀನಿ. I'll just make a list in the equation, and in the next session we are going to have one problem with respect to DIT-FFT, and we are going to just understand how it's going to work with respect to the problem, and we are also going to learn another problem with respect to point, and I'm going to showcase all the things in the textbook because I can't just write the diagram, right? Writing the diagram makes me a lots of time. So instead of writing the diagram, I'm going to showcase you in the textbook in a clean and neat manner, and I'm going to have all the things in detail, right? And this is what I was about to tell, and please do like, share and subscribe, and share it to many more who are in need, and please do press the bell icon to get more and more updates on our channel, and thank you.